Hello, everyone. I'm recording the San Diego C Meetup. This is May 2026. Today is the 26th, meeting number 86. So I announced it in a very short notice. I think it was like yesterday or the day before. I'm super busy lately, and I have about 45 minutes worth of material that I still want to post, even though this is uh, just a recording with myself, and I'll post it online, and people can take a look at the recording and ask questions over Discord. Um, Apologize for the last minute notice. Hopefully, we can go to a regular cadence next time. So this is what I had in mind. Welcome and intro. So we meet every month. Again, today it's kind of unique. I didn't have enough time for people to get their schedule aligned with mine, and it's pretty much last minute. I usually have CPAPA's quiz from the CPAPA's quiz website, and then something that I've seen in Twitter, which is kind of a nice thing to look at. That's the third item in the agenda. The fourth one is copy then mutate versus designated initializer in various use cases, and then error handling, specifically on looking at stud expected, which is in CPAPAS 23, but we'll see if you are in earlier or pre-CPAPAS 23 standards, there are also solutions for that. If you have anything that you can think of that you would like to present in this meetup, please approach me through Discord or LinkedIn or any other in any other way online. We have a Discord channel, and ask me through LinkedIn or email if you don't have the link, the invite link. Yeah, my name is Kobe. You can see me online in any kind of medium, Discord or LinkedIn or email or Twitter or anything else. We have a calendar through luma.com. We moved away from meetup.com to luma.com. SDCPP Meetup, MU, is our calendar, and it's also the name of the YouTube channel. Okay, so let's take a look at 3 different questions. They're kind of fun questions. Let's start with 135. Oh, before that, yeah, YouTube recording. I'll post it. This is the Discord updated link, and some packet discounts. I don't know if they're still valid. You can give it a try. Okay, so the first one is 298. Okay, so let's share this one. So what are the options here? It's either let's go to, there are few options here, and just give it a thought. So we have struct S and then throw and then another throw. So is it no throw constructible? So it is throwing, so no. It is throwing, so it's not no throw. How about destructible? So this should be yes, because it's not gonna throw, because it is no throw by default. And this is going to create, it should be saying here some when you try to throw from a destructor, and your destructor is no throw, which is by default, you get terminate. I don't know if it says here that you get terminate, but it should say something. But basically it is no throw. Okay, let's go to the next one. 135. Okay, so we have a map bool_int with these values, and then we have map of and what is the size, and then map int and what is the size. So since this is Boolean, so 1 is true, 3 is true, and 5 is true. So all of them would be the same entry. So this would be 1. But int and int are all 3 different entries, so it's going to be 3. So it's 1, 3. Very clever, kind of a very, I like this question. Okay, and the last one. Someone wants to join. Okay, I was admitting someone, but I don't see this person. Okay, so next one is what is 174? Okay, let's get rid of this one. Hey, John.
Hey, what's up?
Yeah, it's basically you're the only one on the bridge. I realized that it's gonna be tough because I give people very short notice. So
Okay. Well,
I'm go-
if you're going to continue, then I don't mind learning and listening in.
yeah,
Um,
I'm continuing. I'm continuing. It should
okay.
be about half an hour
Sure.
worth. So if you want to stick around and ask questions and all that, be my guest.
Yeah. I'm just absorbing here, so thank you.
Okay, cool. So this is the third C++ quiz. We have this function. So integer is x, and then we send x and x. So this is x, and this is const x. So the first one would be probably 0. And then we assign 1 and print b. Since there are references, it's going to be 1, which is it's kind of very basic. The fact that b is const reference doesn't guarantee that b isn't modified from it, but we cannot modify it. But when we have b printed, it's going to take whatever a has because it's a reference to x. Okay, so let's continue with this one. Okay, this is something very nice that I've seen on Twitter, and I thought, okay, this is worth small discussion. Void pointer is not void pointer, which I never thought about it like deeply about like this specific subtlety. So that was I think this is taken from the Twitter where you have a equal whatever, and then you have a pointer to a, and then you have void pointer to the address of b, and this is not compiling. And the slide already says that the generic part stops, which is void pointer, one level of indirection. So void pointer is special. Void pointer is not the same as void pointer. It's not like you have unlimited levels of ways to treat a type like a void pointer. So let's unpack it one at a time. Okay. So the key thing here is that void pointer is special. in C and C++, kind of a universal pointer. So let's take a look at what's happening here. So this is the same as what the Twitter had. So this part is fine, right? There's no void pointer here. It's just void pointer. So you have A and then something that points to A, which is int. Everything is fine with the type system. And then you have void pointer to B. Any T pointer implicitly can be assigned to void pointer. We are all good here. I can go back from, this is C, so it's a C cast. We can go back from V to P, so sorry, to Q, which is in pointer, everything here. And this is also working for double, like any type. Like you can take an address of D, and this is going to be a void pointer. But this does not mean that I can take a pointer of an integer, store it here. So the type system says B is a pointer to an integer. I cannot take the pointer of this, an address of this address, and say, okay, this is void pointer. Like this is not gonna work. Okay, let's understand why. Like what happened if it would work? Like what kind of issues it opens up? Okay, so let's say hypothetically that this is working. Like I can take an address of A, and B is in the type system. B is a pointer. It's like the value here. It's an address of an integer. It's an address of an integer. That's the important part. Now I take the address of this variable and say, okay, this is pointer. Okay, so far let's say it is fine. Now I have float. Okay, float has a different encoding, right? There are different things that are encoded in the bits of float, like the way we treat float. Now, I'm saying, okay, I'm dereffing C, and I'm saying now it points to a float. So B, which is this guy, used to point to an integer. Now it points to a float pointer. So what happens if I try to access that, to deref it, but the type system still thinks it's an integer, but actually I'm actually pointing to a float now. So this is something, and we know that it's not going to work because the compiler would not allow us to do that. That would create an undefined behavior because the bits encoded in integer and float are different. So again, just repeat that. Actually, this next slide is actually doing the same thing, but just in steps. And I'll release the slide in Discord so you can take another look. It's the same thing, but with just 1, 2, and 3. So 1, C holds the address of B. So B, the first level is pointing to an integer, and then I take an address of it. Then I have D, which is completely fine. And the address of D, I push it into deref C. That this used to be, it used to be pointing to an integer. Now, when I deref B, this is where things get into undefined behavior. Derefing B, the reference of B as int pointer, but B points to a float now, not an integer. Floats bits misread as integers, so it's garbage. So I try to put here like this kind of what happens step by step. The first one, void pointer B. C stores the address of B. The reference B lands you inside B owns memory slot, right? And then this is the ref of C. So one level in, it's the address of a float. Now we basically tinkering with B value. B value now is the address of D instead of the address of A. So that's something that the type system is saving us from ourselves. Okay, the right fixes. Sometimes we do need that. So void pointer pointer. Sometimes you need that for all kinds of C, ABI, and all. There are multiple use cases that I've seen that we need to do that. But you need to be very careful, like not to end up misusing it. Option 2 stays as void pointer, one redirection. Don't go with pointer pointer. You can still have double indirect via real void pointer. So you have a temp equal B. Now remember that everything can be pointer of void. So B goes there. If you remember, B was a pointer to an integer. So you can still, and this is fine. This is, you satisfy the type system. So void pointer is special. Void pointer is not. This one, the type promises extend through every level of indirection. There is another slide. So what it means that every level of indirection must match the exact type. So you are responsible for that. Okay, so either this part, which we just saw, or some casting, either C-cast or reinterpret cast, which is also fine. Be still typed as int pointer in memory. If you start writing back, it's a UB technically. So you need to understand that this is what exactly it holds. C API interrupt, yes, this is mostly the use case. Okay. Copy then mutate versus designated initializers. So this is just a small subtlety that I wanted to highlight. I don't know if you thought about it, but here's a struct, and I'm using non-static data member initialization. And everything here is 0, 64, and 6 are the defaults for protocol. Just something that we invented. Now, this looks clean, but it could be secretly broken if you start using designated initializers, but you don't realize that you put TTL and protocol, and you're leaving them as the defaults. Maybe these defaults are not correct for your use cases, but it's hidden in the sense that you're getting the defaults. Maybe this is fine, but sometimes it's not, and you need to change them. So if you forget to mention .ttl, .protocol, and assign, you'll get the defaults. Copy and mutate says something else. You have like the original redirect, and then you can mutate what you need. Then the original, which might have different values, 64 and 6 in this case. So you can see it in all kinds of, this is basically what it repeats what I just mentioned. The interesting part is when you do pushback or in place back and you using designated initializers versus something else like copy and mutate. So you need to be aware that in pushback or in place back, you get 64 and 6. You don't get the other value. Let's say you want to copy this from some base, and the values that you have in initializing members, the non-static data member initializer, which is NSDMI. So basically, that's what you get if you don't mention them. In copy and mutate, you'll get the base, which is 128 and 17, for example, and then you can mutate whatever you have, and then this is not going to inherit the initialized member. So this is a small, subtle difference between these two that can bite you if you're not careful enough. Okay, So this is the last part of today's session, which is stood expected. John, are you using stood expected by any chance? Or something similar? You muted.
No, I'm just absorbing here. So I'm
No, okay. I'll
I'm not
explain that.
Yeah, please. Thank you.
So are you familiar with Rust result?
A little bit, yes.
So it's very, very similar. So let me explain. So not a super comprehensive view of all the error handling journey in C++, but it's a good summary. C and C++ 98, you have error no and return codes, which is very, very simple, right? It's just return codes of like either error no or you return something from a function. We don't have no discard in C++ 98, which is a kind of a missing feature, but we only had that in C++ 17. Then in 98, C++ 98, we don't have it in C, but we have exceptions in C++, which makes it very hard for the caller to ignore. But it has cost. There are some platforms that we are not allowing exceptions. The exception path, when it happens, it's not deterministic. So for real-time, soft real-time, we don't allow that. Now, C++ 11 added some more structure to error code and error category. There is a good CPP con. I think it was a few years ago. I can't remember exactly. It was 2022 maybe, or 2023, about error codes. And this actually, it's kind of a building block of kind of a better structured C++-ish error code that map to the platform errors. And then you have error categories, and there's a whole framework that was introduced in C++ 11. I don't know how many people using it, but it is nice. It is nice building block. Now, the standard library, if you look at some of the functionality, for example, unordered map has insert, which returns stood pair, which has a return value, let's say an iterator, comma bool, which bool means I managed to do that or I failed, like insert happened or did not. So that was kind of one of the ways to indicate error plus a real result if the call succeeded. So we had that for some time, right? This is actually not, I don't think it's C++ 11 even before. Now in C++ 17, we had stood optional, which is not only for error handling, it's also for something that this is also in Rust. There is an option. This is something that says maybe there is a type here or maybe not, but there is no error attached to it. But it's useful not only for errors, it's useful for a lot of semantic where you say, okay, there might not be a value here. It's a value semantic, not pointer. It might not have value because pointer has null pointer, which you can do the same with pointers, but for a value semantic, stood option is a very good vehicle to express maybe there is some value here, maybe not. A lot of functional programming, they have something like that, like Haskell and Rust and others. So stood option is a library not extension, it's a standard library addition in C++ 17. C++ 23 added something that is very close to the result of Rust, stood expected, where you have the value, comma, error. Now, the nice thing about stood expected, and I'll show that, it's the monadic interface. You can chain things, and it makes the code very readable if you do it correctly. If you don't have I have a slide on that, but if you don't have C++23, you are in C++20, 17, there is a library on GitHub. It's a header-only library called TL : expected, which can be used. It has a very rich API, very similar to the one with the standard library. I'll show that. So let's take a look at a few examples. So stud expected, T is the value and E is the error. You can think about it like stud variant, where you have a value, comma, unexpected E, and E would be an error. An error can be anything, can be an enum, can be error code. This is why I said that error code can be the building blocks of something more high level. And now how do you access that? You can deref it, very similar to stud option. You can ask if it has a value. You can take the value with that value. So it's very similar to, very similar to dereferencing. Or if you know that you have an error, you can extract the error by calling that error. Here's an example. Let's type def expected, comma, stud string. So stud string would be the error. And now I have a function named parse, and it returns result. And result is just a type def of stud unexpected, because this is kind of a long thing to type. So even though we don't type these days, right? AI is typing for us, but still, AI is typing that. So instead of that, of writing this whole thing, we just type result, which is type def. And let's say this is a very simple function that if it's empty, there is nothing to parse. And let's say it's an error. It's an unexpected. There's something that we would like to convey to the caller. So we create a stud unexpected, and we put a string. Otherwise, we string to integer. Let's say that's the parsing. So you parse 42. You should get 42, right? But if I give it, let's say, an empty string view, an empty string, I'll get r.error. I can check if it's r. And if it's not, like this is the Boolean part. If it's not, I can extract the error. So this is very simple, right? We'll get into kind of more sophisticated. This is the most sophisticated part, which this is like in a very, very kind of in a nutshell, and you can go and explore more about like how can you chain with circuiting the usage of stud expected. So here's like stud expected, but in a very kind of old-fashioned way. You read a file, you have R1. If it's an error, you can return the error. No error, you continue. You can parse the JSON and you pass the value. You don't pass the stud expected, you pass the value, whatever you parse, whatever you read from the file. Again, you can query, is there any error? If yes, we return. No error. So we have a JSON. We can take this JSON by derefing the stud expected, and pass it to validate. So validate signature has JSON, okay? And then we process that, whatever we got back. So this can be done by using this syntax. You read the file. If it's successful, you call parse JSON with the file that you read, like the buffer. If this is successful, then you validate. If this is successful, you transform. So transform takes the function process. It takes some T and returns U. So this is like the last part of the. So it doesn't return expected. It actually returns the actual value. So this is a very common way. Now, if you know Rust, this is like the question mark operator. So I hope you think that this is useful, but it takes time to get used to it. I agree. What do you think about that?
Can you hear me?
Yeah, yeah.
Oh, okay, yeah. So I haven't done too much in the Rust as well, or mainly just absorbing and learning, but very cool. I'm following along pretty well, I'd say. Um, how do you see these patterns kind of sort of like these approaches in cloud infrastructure and like distributed systems
Yeah,
applying?
we tried everywhere,
Yeah,
and we got a very good results. It is taking time to get used to, and I can tell you that I need specifically to ask AI agent harnesses that are they have some whatever LLM, can be a Claude or
yeah,
Codex or whatever.
yeah,
You need to tell them you need to use the monadic uh, interface of expected to get this syntax, the one that you see here,
yeah. So it's
because
really about knowing
yeah,
and
they,
being
yeah,
specific, right?
yeah. You need to be specific. Now, what to use when? Like stood
Sure,
optional. Sorry,
sure. Go ahead.
I'm saying like if you're confused about like when what to use, because I've shown all kinds. So stood optional is it can be used for errors. It could like you can return nothing, and then for you deduce it's an error and you continue, and it's very cheap. Stood expected has it's not an exception, right? You have a failure that is actually attached to this object, right? And you, in case there is no failure, you have the actual data that was passed in the return value. Exceptions is really for exceptional cases. You don't want to use exceptions for returning or something that happens quite frequently, because that is not usually that would kill this path in terms of performance. Now, if you have
So,
CAPI and
so you mean as
yeah,
far as like operational reliability and performance?
yes, in
Okay.
performance, like because you don't, there are few reasons for that. The exception handling might be in uh, a very far page of the text code. There is a very good CPP-Con uh, presentation talk about exceptions. I think it was part of the likely and unlikely presentation. But in terms of performance, it's really for exceptional cases where you don't want the caller to ignore that. Very hard to maybe to recover, and it needs to go all the way up to the initial caller to make decisions, and it's something that maybe it's not like I parse the file and it's okay if I don't if I get a mistake, maybe I can do something else. It's not like a catastrophe. So exceptions, I see it as, oh, this is catastrophe. Like the device, you're working with a specific device, and the device is not online anymore. So this is really okay. Like we might need to restart the process. Like you cannot recover from that. Like these kind of things might worth having exception. And there's a lot of platforms that they don't allow exceptions, and they're still working well with error code and something like either optional or stood expected, kinda. It depends. You see a lot of them working with error codes, error null, and error category and error codes. It's something the kind of a more high level that was added, and specifically error code works relatively well with CAPI. Like you can extract the error and just use it with the CAPI. So just few examples that highlight more in the power of stood expected. So stood string as an error, just type def and result. This is something that we saw before. So same deal. That's an example that we already saw. Enum. So you can have, instead of string, you can have enum. And if you have reflection in C++26, or maybe an enum library that you can take an enum to a string, and similar, there are at least couple github.com libraries in C++ that take enum and create a full framework that you can iterate. You can create a string from that. So enum is a great thing. So you can switch on the error if it's an enum, and you can do stuff, which is very, very good, kind of semantically speaking. And you can have a full struct that is holding the error code, the message, the file that had the error. Like you can have that also as part of the error. So that's a bigger payload of the error. And as I mentioned, you can do stood error code. So this is kind of an example of an error that is, let's say, no such file or directory. This is why I said it's mapped very well to your platform errors. So you can have the error code, stood error code, as the error, and then you can basically use it in when you call the function and it returns stood expected. So that's something that is also, we're actually using in some of the code, we use this kind of syntax. So make error code, error category, all of that. If you open CPP reference.com, you'll see this whole family, and there's examples of how to use that. It's not complicated, especially with AI. You can ask AI, okay, I have these error codes, make them available for me. Okay, so we already saw that there is an additional or else. So this is the manual way. You have read file, if not stood unexpected, with the errors. And this is the one with, okay, this is the one with the with stood expected. Return read file, that then pass it, then validate, then transform, and then we return the report. And then we can call generate on P. And if it fails, there is or else. We can take the error. So or else is where, if it fails, take the error, you can log it and do something else. You can do parse of s, that the value, or 0 if it fails. So that's another way to get a value or alternate value in case there is an error. So there's a lot of very nice and convenient API that can be used instead of if else. Like, think about it, that would be an if else if you need to do that manually. This is with exceptions. So not having stood expected, but this exception. So you have compute, divide something, process also might throw, and then catch. In stood expected, so you don't have exceptions. You have divide that returns something, and then you check it. So this is a new syntax in 17, if I'm not mistaken. And then if it's valid, you continue to process. Otherwise, you log it. But there is another way to do it, which is divide AB, and then take, if it succeeds, take that and run it on process. But if it failed, just log the error. And log error, it's a function, for example, that logs the error, like it's running something like that. So this is the monadic style of this manual. And it takes time to get used to it, but if you know Rust is like, this is like the idiomatic Rust approach. So they have it like from day one. When people learning Rust, I think they kind of understanding and learning. There's a lot of monadic style in Rust. Okay, almost done. If you don't have C++ 23, TL expected, the github.com, either MIT or something very permissive. And you can see that the API is very, very similar. Instead of unexpected, there's make unexpected, which is very similar. But you have and then and transform, and it looks very, very similar, if not identical in this case. So if you don't have C++ 23 and you want to move into a more expressive style, you still have hope. Okay, stood expected. Sorry, TL expected, and there's also expected light. I'm not familiar with expected light too much, but I'm using TL expected here. All right, so this is my last slide for today. These are all kinds of interesting news that I've collected. Structure binding, standard library hardening, and so on and so forth. Before we leave, another minute, I want to show you something. If you don't know Notebook LM, it's really cool. I took a C++, oh, I'm not sharing. Share this stuff. Okay. Do you see it? Yeah. So Notebook LM. Notebook LM is something from Google. It's free if you have Google account. So I took the C++ standard. It's a link. Let me see if I can put the link. But basically, it's a link that was distributed by Henrik. I don't know if I pronounce the name correctly. He has this book about HFTs, high frequency trading. But the interesting part is that you can put it in your Notebook LM, and then you can see the various areas where this blog post is talking about various things that happened to the standard library throughout the years, and what happened, what went good, what didn't go well. And there's a lot of things. I don't know if are you familiar with that, John?
I haven't used this one yet.
So Notebook LM is like one of the, like Notebook LM, you put resources that you have and you can start exam. You can put a book here. You can put various types of links, and it's like a sandbox. You just look at your resources, and there is an LLM that runs, and you can ask it questions. You can create a map of the resources, like how it links, and you can do a lot of things. Like you can see here, you can create a podcast, create a slide deck. It's all, this is nice. I created an image from the, this is an image that we created. Cool. So you can, just by looking at the image, you can understand what this article was trying to convey. There is auto pointer that was deprecated. And then there are all kinds of avoid this list, like std regex, std list, because they have a very bad performance. And then core containers, which are could be fixed, but we cannot fix them because of ABI constraint. You see this anchor, because the ABI stability anchor is like what makes C++ having this baggage. And C++ native with the standard template library that is shipped, for example, unordered map and list, it's slower than Rust. But if you take optimized libraries like vector, B-tree map, flat hash map. It's very, very fast, faster than Rust, maybe. And then it talks about the Vasa problem, about the language adding a lot of complex stuff that might not work together. So everything that, so I just wanted to, I don't know if a lot of people, they're not familiar with Notebook LM. I just wanted to show that. And this is your chat. Like you have a chat window where you can either click on predefined questions or you can ask questions yourself. And you can add sources. You can take a look at all kinds of sources. And I just want to see if I can quickly show you the link. It's interesting. Like, how can you take? Like, if I click here, oh, maybe here.
So you're trying to do a link of your source or just a share of the
No,
notebook? Because there's a share button.
I provided. I provided the PDF.
Yeah,
it wasn't the link. I provided the PDF. So what happened is that the link was behind. Are you a human? And it's okay. I can't use the link. So I just print it as a PDF, and that's it. So it's a PDF. So so it's a very cool way to learn things, not only C++, but in general.
It seems like you can learn complex system topics really quickly, especially going through architecture reviews and onboarding even for people. Absolutely.
Yeah, you can have flashcards because if you want to learn it, like it's pretty strong. And I know that a lot of people don't use it. Now there is a way to have a Cloud Code Notebook LM. So there is a Notebook LM skill that you can take Cloud Code and create a skill from. So you can actually access your notebooks from Cloud Code, which is amazing. Like think about Cloud Code now have access to information that you already digested, which is like very, very strong.
Very cool.
Yeah, that's it.
Very cool. Thanks so much.
Yeah, thanks for sticking around.
Yeah, absolutely. Sorry, I was a little late. I had
no worries.
prior meeting with somebody, so I was just happy to come on and learn a little bit. So thank you so much for running these.
Take care.
Bye.
Thanks.
Bye.
Bye.